Hi, I'm Cheyenne Lupton, and this is my second video for Exam 5. This will be on quantitative genetics. In this case, the goal is to improve the population through breeding. In this case, I am using the length of a giraffe's neck as my trait. Let's say we take 100 giraffes, and they're all in the top 10% of their population for the length of their neck. The average neck length for this population is 6 feet or 72 inches long. The standard deviation is around 8 inches. We're assuming this trait takes on a normal distribution. A histogram for this trait is shown below. This trait has a 0.85 broad sense heritability, which means that 85% of the variation is due to differences in genes. The realized heritability, or h squared, is 0.67. This is the proportion of variance due to additive effects. We can calculate the truncation point of this population. The truncation point is the point at one of the tails of the distribution that we choose to breed with. They're at the highest end of the normal distribution. This is found by taking the z value found in a table and multiplying that by the standard deviation and then adding the mean. In this case, the truncation point is 82.256 inches. Now, because we selected the top 10% of the population, we can use a selection intensity of 1.577. This value is obtained in a table. To find the selection differential in this population, take the selection intensity and multiply it by the standard deviation. This makes the selection differential, which is the difference between the mean of this population and the mean of the selected parents, 14.04 inches. Using this, we can add the selection differential to the original mean of 72 inches and get the mean of the selected parents, which is 86.04 inches. The response to the selection can also be calculated. This is done using the realized heritability of 0.67 and multiplying it by the population of the mean of the selected parents. This value in this case is 9.4068 inches. We can then use this value plus the original mean to find the mean of the offspring. All of the distributions from the original mean, the selected parents, and the offspring are shown below. It is important to note that if this experiment was done many times, the average neck length would decrease because it is likely that a rare bad trait could emerge, making the population shorter.